Range active. What are we doing today? Well, for about the last 12 months, actually no, it's been 2 years now since I built this prototype. This is connected to an infrared beam across my driveway. This is the sign component, which also houses all the very poorly built electronics, driven off a DigiSpark module here. But what happened recently is we had a power outage. It was a scheduled outage, and sometime after that this died, along with some other electronics. Seems to be they can't disconnect and reconnect power without causing a massive power spike. So I've replaced the DigiSpark today and it died again, so I have a few of them spare. But I'm thinking it's about time I just stripped this whole project to pieces and built it properly. And before you notice, this is actually a cordless doorbell unit that usually has a built-in battery. I want to power that from this unit. I found that having a built-in battery was a problem. I'd set it up so that if somebody cut the cable, the doorbell would immediately go off. The problem I had with that is that when people would park in the beam, the battery would go flat, and also if we had a power outage, it would go off until I had to go out and do something about it. So I'm going to fit an uninterruptible power supply to this, but in the meantime I need to rebuild this entire box. Okay, well, it appears to have exploded with some help and time, and I've also had to engage the air conditioning. So I've pretty well stripped out everything. The replacement DigiSpark I put in actually works fine. I've been able to reprogram that, but the old one is shot. So in any case, I'm going to proceed with the build, and let's get rid of all this junk off the table and start from scratch. Alright, so I'm taking a slightly different format for this video just because of the way I need to get this done. I'm just keeping you up to date now. I've got my two panel mount LEDs already mounted. I have the cable gland, and I've got my bypass switch just in case somebody parks in it for a long period of time. Now, for you, those of you who are going, well, why doesn't somebody just come up and switch it off? Well, to get to this switch, you've got to cross the beam, and there's no real getting around it. And I've had the most nefarious people I know test that principle. So far, nobody's got past it. In any case, this is just purely an early warning system, mostly aimed at sort of unsolicited door knockers and the occasional Jehovah's Witness. However, no disrespect to the Jehovah's Witnesses, they've been quite respectful when I've asked them to leave, unlike some of the people trying to sell me unsolicited solar panels. Rant aside, let's get on with this build. Now, before we get too involved, I need to test this unit, so I'm going to turn on the main supply here, and I've got a DigiSpark booted up. We should see the onboard LED light up. I'm going to touch pin 0 here just to simulate a beam cross, and it should wait 2 seconds, run the cycle, and then return to its original state. And that should do that consistently. There we go. I'm just using the induction from my fingers. You'll notice I'm touching up here with this finger and this finger on ground, and there's enough resistance through me to pull that pin low, which should simulate that pushing down. It's a bit of a hodgepodge method, but it does mean that that DigiSpark's behaving normally. Rightio. Okay, so one of the problems I've actually identified is that the built-in regulator on the DigiSpark here, which is the most prominent large three-legged chip there, is really not up to the task of running a big 4-channel relay like this, or relay board. So I am switching to single-channel relays. It's hard to do one-handed, and I'm using this LM7805 regulator here, a linear regulator. It should run them quite fine. I probably won't need a heatsink considering I'm not going to pull anywhere near 1.5 amps, but I think that might be some of the problem when it's been turned on and off rapidly, such as with a power outage. So we'll see if we can do that, and we'll tap off the 12-volt line to directly run the doorbell transmitter. Okay, it's smoke test time, and only now I realise I've got a couple of LEDs out of line, but I'm going to have to deal with it. So this should look a lot more sensible than the last one. I've left the DigiSpark loose for the moment until I'm sure that it's working. That is stuck down with hot glue. I'm not sure how long that will stay that way until it gets hot, but I've used DuPont connectors on a whole bunch of things, including the LEDs, so that the front panel is removable. So let's fire up some power. Okay, we have a green light on here, and it's gone off. That's as we would expect. I've got some lights on these. See if I can touch a relay, and that should have set off the doorbell. Okay, that should work well. Okay, and see what else is happening. Oh, that's good. Okay, so when we touch this one, it should briefly send the doorbell off. Okay, and then wait a few seconds and alert the buzzer and that somebody else is at the door. Right, so somebody walks across, doorbell immediately, a few seconds later, warns the people outside. That makes it a little bit harder for them to detect the actual position of the beam. So let's just try again. Okay, we have an auxiliary input I've obviously configured for some purpose. I don't recall what that was, but I'll change the program later. Okay, time to add the doorbell system in. Okay, I've taken a little bit of time to neaten the wire up here. And yes, I've used solder for wire wrapping, but at least I can see what I'm doing. Most of these parts are recycled in bits and pieces, but smoke test time. We have the doorbell circuit in situ, so let's fire things up. No. What did I do wrong? Things didn't immediately fire up. Ah, I'm going through the power switch. Let's turn the power switch on. Right, our lights on, and they should turn off after boot. Yep, okay, now let's touch our trigger wire. Where are we? Down here. So let's try this again. Let's go. Touch the trigger wire. Oh, I need to touch it with my finger just right. Okay, rightio. So that seems to be working. Now I've got to find the pinouts which are written on the old box, write them on this one, and get the right wires configured for connecting back to the cable. Right, it's a little windy out here, but let's see. We have the whole thing attached now using solderless butt joins. So just those little heat shrink tubes with glue and low temperature solder in them. It's time to go smoke test everything, and we can see one end of the receiver here. Okay, it's slightly messier than it was, but I had to make a couple of alterations because I discovered it was pulling low when it should be pulling high on the trigger pin. But time to get it all put together and get my apprentice out to test this. Got my apprentice ready to help?
Just wait.
Okay, let's run through the beam. Come on. Run through the beam, test it out for me. Straight away. There's our buzzer. Okay, this way again. Back across the beam. See if you'll trip it. Okay. We have success. Test the system while we're looking at it. There we go. And it should. Right. And that second light will turn on and off at random intervals at different times, just to keep people on their toes when they're not sure if it's on or off. Well, after all of that testing, it's time to do a battery change. So, I hope you guys have enjoyed this video. I'll leave you with an iconic scene from my battery box. And we'll be back again soon, hopefully with something a little more interesting and perhaps a bit more retro. I have recently received some donations, but you'll see them in another video. In any case, thanks for watching.